Okay, so remember that we are trying to really look at the graph of e to the x and the ln of x because we're going to use those a lot next year in calculus. And those are the two graphs. Remember, we really want to know these are two special points. E to the 0 is 1, so the ln of 1 is 0. If you went over to e, which is 2.7, you would get up to 1. Okay, and then we talked about end behavioral functions. That's looking at the limits as x gets really big or x gets really small. So if I look at the graph of e to the x, as I go further on the x, the outputs get larger and larger. So we're going to say that's plus infinity. Versus if we come to the left, we would essentially be having e to the negative number. So it's 1 over e to some positive number. And that's going to go to 0. Okay, now if we go in G, it looks like it's leveling out, but it's really not. It's just going up really slow. So as x gets bigger, the logarithm gets bigger. It just takes a really long time. So this is plus infinity as well. Okay, then we talked about one-sided limits. So let me get a different pen. Okay, and now we're going to look at approaching 0. Either from the right or from the left. Okay, now if we look at f from the left, you would think you would get 1. And you would think you'd get the same number if you came from this side. And remember, that means that the limit as x approaches 0 of f of x is 1. Now it's a little different if we look at ln of x, because if we approach from this side, the closer and closer we get to the y-axis, the lower and lower the outputs for ln are going. So that is negative infinity. But if we try and come from the other side, there's no points there. There's no outputs if the input's negative. So we say that this limit doesn't exist. So the D stands for does not exist. Okay, so the interesting thing about limits are sometimes you can't find an output number, but right around that point, you would expect the output to be a certain number. So here's a case of that. So here's this crazy function. Did you put it in your calculator? And we want to find the limit as x approaches 1 from the negative. So let's think about the input numbers. Okay, so we want to be close to 1, but we want to come from this direction. So what's the number kind of close to 1? How about if we do 0.9, 0.99, 0.999? So if you put this in your calculator in y1 and evaluate y1 of 0.9, y1 of those other things, you get 1.64, 1.96, 1.996, and you're like, that's going to 2.